Hi everyone. Now we are going to discuss about another one transistor circuit, and here we are going to find in which region the transistor going to work. Here we are using the NPN transistor with base to emitter junction voltage is 0.79 volt and the saturation voltage between the collector to emitter is 0.14 volt. This is the collector and this is the base and this is the emitter. And here we are using the common emitter configuration. So initially we need to find the base current. Here base current IB is equal to 10 volt minus VB divided by R2, which is equal to 10 volt minus 0.79 volt divided by 500 kilo ohm, which is equal to 18.42 microamps. This is the base current which is flowing through the base terminal. So now we will assume the transistor working in the active region, so that collector current IC is approximately equal to beta times IB. So which is equal to 100 times 18.42 microamps. So when we simplify this, we will get 1.84 milliamps. That means when the transistor operating in the active region, its collector current will be 1.84 milliamps. As you know, collector to emitter saturation voltage will be 0.14 volt. That means when the transistor operating in saturation region, the voltage between the collector to emitter junction will be 0.14 volt. So that in the saturation region, collector current IC sat equal to 10 volt minus 0.14 volt divided by the collector resistance 2.4 kilo ohm. So which is equal to 4.1 milliamps. This is the value of the saturation current. And we know IC is equal to 1.84 milliamps and IC sat is equal to 4.1 milliamps. So that collector current IC is lesser than the IC sat. As you know, collector current is lesser than the collector saturation current. That means transistor will not operating in the saturation region, because here collector current is lesser than the saturation current. So that it should be operate in active region. To confirm that, we need to verify whether the base to emitter junction is forward bias and the collector to base junction is reverse bias. To confirm that, we need to verify base to emitter configuration and base to collector configuration. If the base to emitter configuration is in forward bias and collector to base configuration is reverse bias, then we can call it as active region of the transistor. Here base to collector is in forward bias condition, so that the base voltage VB will be 0.79 volt, and we need to find the collector voltage to conclude whether this collector to base junction is reverse bias or the forward bias condition. So that collector voltage VC is equal to 10 volt minus IC into RC. So which is equal to 10 volt minus 1.84 milliamps into 2.4 kilo ohm. So when we simplify this, we will get 5.58 volt. That means VC is greater than the VB, and the given transistor is NPN transistor. That means collector to base junction is in reverse bias condition. So we can conclude that this transistor operating in active region. Let us verify in the simulation. Base voltage will be 0.79 volt. Similarly, our base current will be 18.42 microamps and our collector current will be 1.84 milliamps, because here we have considered beta as 100, and our collector voltage will be 5.58 volt. By considering this simulation, we can conclude that this transistor operating in active region. Please comment the resistor R1 and R2 to operate transistor is in saturation region. Hope you are able to understand this circuit. Thank you. Thank you for the watching.